Now that you know how to write chemical formulas, you should understand what is the significance of the chemical formula. Let's give a very simple example. Imagine that the formula is called barium chloride. You probably remember that in order to write this formula, you have to figure out the charge because it's ionic. Barium is positive 2 and chloride is negative 1. And since we don't have to do all that work anymore, we can figure out that the formula of barium chloride is BaCl2. Why? Because you need 2 chloride ions to be involved in forming this compound. So what is the meaning of this chemical formula? It means that there are how many barium atoms in this formula? There are 2. I'm sorry. There's 1 barium atom in that formula. You can see that right here. There's 1 barium ion, therefore 1 barium atom. What about chloride? How many chlorides? There's obviously 2. And the formula actually shows that. There are 2 chloride atoms, and there's 1 barium atom. You might think that this explains itself, but let's take a look at some more complicated formulas, and you'll see it's a little harder. Here are some questions from your most recent quiz. I hope you remember that this is called iron, Roman numeral 3, iodide. Go back to your notes to find out why it's called iron 3 iodide. So let's take a look. How many iron atoms are in this formula? There's 1. How many iodide atoms are in this formula? There are 3. That's called counting atoms. That's the significance of this formula. Let's take a look at this next example. This is manganese 2 chloride. Again, check your notes to try to remember why that's called manganese 2 chloride. But take a look at the number of atoms. How many manganese atoms are in that formula? 1, that's correct. This one right here. How many chloride ions are in this formula? 2. And that's the significance of that formula. Manganese 2 chloride is made of 1 atom of manganese and 2 atoms of chlorine. You can try this next one on your own, but I'd like to get to this one because this is a little bit more complicated. Hopefully you remember that that's called tin, Roman numeral 4, periodate. Let's try to understand how many atoms of each element are in this formula. What is the meaning of this formula? It means something like this. It means tin, and this polyatomic ion, periodate, but there are 4 of them involved, right? So this will make it a little easier to count if you write it out this way. How many tin atoms do you see? There's only 1. How many iodide? There are 4. And how many oxygen? Be careful. This is where it gets tricky. There's 4 here, 4 more, 4 more, and yet another 4. And so there are 16 atoms of oxygen in one formula of tin 4 periodate. You can tell it's a little bit more complicated. Let's take a look at the next questions from the quiz. Chromium 3 sulfate. Hopefully you remember that the formula of this is Cr2 parenthesis SO4 parenthesis 3. Let's count the number of atoms in this formula. How many atoms of chromium are in this formula? There are 2. Now it's a little trickier. How many sulfur are in this formula? You'll notice this says that there are three polyatomic ions called sulfate that are involved in forming this compound. That means that there are 3 sulfur atoms that make up one formula unit. And finally, what about oxygen? There are 12. You'll see it's becoming easier and easier because you're more familiar with it. It becomes tricky when you're working with polyatomic ions that have parentheses. Let's take a look at this formula. This is copper 2 phosphate. The formula is Cu3 PO4 parenthesis 2. Again, check your notes to figure out why that's the correct formula. Hopefully you can now figure out that there are 3 copper atoms in that formula. Hopefully you're more familiar with it now, and you know that there are 2 phosphorus atoms in that formula. This is the trickiest one. There are 8 oxygen atoms in that formula. I'm going to skip tin 4 chloride because really the most complicated one on this chart is lead 2 acetate. This time I'm going to write lead 2 acetate this way. Pb parenthesis C2H3O2. Remember, this is the alternate form of writing acetate ion, right? This makes it easier to count the atoms. Why? Because there's 1 lead. And remember, there are 2 polyatomic ions called acetate that are involved in this formula. There are therefore 4 carbons. You're right, Will. And there are 6 hydrogen atoms and 4 oxygen atoms. So now we're going to do a few more examples based on your previous worksheets so that you can really understand this very basic concept.